What's up, Algebra? I wanted to make a video about the function of the day just because of it's something that we've been doing really kind of specific ones. We've been doing only stuff where it's like, hey, we have 0, 3, and 2, 1, and those were like just a couple points like there and there. And it's like, hey, what do you know about that stuff? And that's fine. But today we have fast forwarded to this function right here. And you might be thinking, holy cow, that's a whole lot different. And you're right, it's because it's not just 2 points. But we have kind of, used these little braces to kind of say, hey, listen, our function is here. But notice we have 2 parts to it. There's this blue part, f parentheses x, and then equal sign. We're familiar with an equal sign, and then there's just an x. So the first thing I wanted to do was just kind of launch into telling you that this thing, the blue part, that is called function notation. Okay, oops, there we go, function notation. Meaning that they have written the function, and I'm going to write and say it as it's read. So if you're like, what the heck? Okay, so when I read this, I don't just say f parentheses x or f times x. I say the sentence f of x. F of x. And then the other part is how you would think it equals x. So equals x. That green part, exactly what you would expect. And I want to tell you why is that. Well, it's because this is a line, or I guess you could say it's a linear function, okay? And notice that I wrote line, and then I said it's a linear function, because if you're ever confused on, well, wait, what exactly am I looking at? Well, you're looking at a line when it's a linear function, okay? And so here's the idea of why would we do this? Why would we have f of x? Imagine that you had a business and you're tracking the products and how well some of those products are doing or not doing. And this is like bananas, and this is carrots, and this is tomatoes, and this is gummy bears. I don't know. It would be easier, instead of just saying, well, this is y equals something, y equals something, y equals something, y equals something, to say that this is c of x, g of x, t of x, b of x. And I get it. In English, we would just say, this is carrots, this is gummies, this is tomatoes, this is bananas. But in math class, if you're ever building something that you need to, in order to represent all of this, which we can and will do, well, then it would just be nice to refer to them by one single letter, right? Okay. So now let me make this not in function notation. Let me get rid of the function notation, and it's like this. So here's another bullet point. Y equals x. That is it, and not function notation. So one thing I hope that you kind of notice is that y is f of x. They're the same thing. And one thing we talked about is that this y is the range. It is the output. And so our buddy here, x, he is the domain. He is the not the output. He's the input. He is, x, I guess. So anyway, what I'm getting at is, now I'm going to ask you to, okay, well, why don't you give me an input of a number? So, okay, if you give me an input, that means you are changing the x. So what if you were to give me 3? Well, I want you to notice what just happened. This now says y equals 3 because we chose x equals 3. So check it out. Now we happen to have y equals 3 and x equals 3. We can put that on this graph. So where does that happen at? Okay, well, here is 1, 2, 3. That's where x equals 3. Here's 1, 2, 3 for y. So boom, that is the point. 3, 3, or x equals 3, y equals 3. And I want you to notice what happens if we are to pick other inputs. Let's say we choose the input as x equals 9. Well, guess what? When you take that and plug it in here, you get y equals 9, okay? In fact, here, maybe I'll put that arrow back. There we go, y equals 9. So now, check it out. We go to the graph. We move over to where x equals 9, which is right here, and y equals 9. Not right there, I guess. 10. Is that 10? That's probably 10. And this is 9. So over. Here we go. That is 9, 9, where x equals 9, y equals 9. So maybe you're noticing a pattern, kind of hoping you're noticing a pattern of, oh, well, not just a pattern, but they're telling you, hey, listen, y equals x every time. So whether you choose 3, 3, 9, 9, -5, -5, -10, -10, you are going to get dots like that. And then now, here's the fun part. Here's where it literally is a line, because check it out, we can connect all of these dots. And one thing we technically need to do at that point is slap an arrow on either end of this line, because it's infinite. This line goes on forever in this direction and the other direction, because no matter what you put in, you're going to get that out. And that's kind of where we stopped today. There's a lot of stuff we could say about this. And when I say we stopped there, technically here's what we did next. We went and looked at, like, here were the answers they gave. And I just want to run through these also real quick. So we said linear function. We didn't say it was a relation, but it is. We didn't say it's continuous, but yeah, if you think about it, that's a continuous straight line. And we didn't write the definition of that, but also the definition of that is fairly, you know what, if things continue, what they are. A positive slope means that this thing goes up and to the right, up and to the right, like that. That's positive slope. It's increasing, which also has to do with, like, the slope is that, hey, we're going upwards as the graph goes to the right. The slope is specifically 1, meaning that for every 1 it rises, it runs over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Now, if you're like, well, wait, you went up like 5 over 5. Yeah, do you know what 5 over 5 is? It's like 1 over 1, right? Okay, so there's slope. Other things that, we would know, we just didn't really go super deep into it. These 3 right here crosses through the origin, which is right in the middle. The y-intercept is that. The x-intercept is that. We didn't talk about the domain and the range. Actually, we did talk about them being all real numbers, but one of my favorite things about class was someone said, hey, what's with the R glitching out? And in math class, if a letter looks odd, it's probably because it's trying to communicate something. This is the symbol for all real numbers. So that's fun. And then one thing I said in class but failed to say on the video so far is this is our first parent function. And if you're like, what the heck is a parent function? We will talk about that. But there you go. This is our first parent. It's our first linear function. And it is the function of the day. See ya.